Hi, my fellow scientists. Welcome to ODE1. We are looking at linear differential equation of the first order integrating by the method which is called integration factor. Here we have dy dx. We are going to solve dy dx plus 2y tan of x is equal to sine x. So when we are using method of integration factor, we compare this equation which we are given with this general equation dy dx plus py is equal to q. Then from there now we make use of integration factor, which tells us that it is given by exponential integral of p dx. That is the integration factor. Now when you compare this equation with this general one, p is the function which is corresponding to y. So in this equation, our p is 2 tan of x. So where you have p, you substitute it with 2. So in 2 tan of x integral dx. So you substitute it with that there. So this can be written as integral. 2 can be taken outside the exponential 2 integral tan of x dx. Now on how to integrate tan of x, I have provided a video. I have already taught calculus 2, or you can remember from your calculus 2, because OD1 requires the prerequisite of the knowledge of calculus 2, that is integral calculus. But for those who have forgotten, kindly you can check in my YouTube channel so that you see how we integrate tan of x dx. I will also provide the link below for you. Now when we integrate tan of x, the result is so the result here will be exponential 2 natural logarithm of sec of x. We can write exponential natural logarithm of sec squared of x. This will give us sec squared of x. So our integration factor, it is sec squared of x. So what we do now, we multiply this equation with the integration factor. So we are going to have sec squared of x multiplied by dy over dx plus 2y sec squared of x tan of x, which is equal to sec squared of x sine of x. That way. Then the left hand side can be written as follows. We can reconstruct the left hand side as d of dx in bracket y sec squared of x. All this is the same as this, because when you differentiate this by product rule, you want sec squared of x constant, you are going to get sec squared of x dy dx plus, now you want y constant, so you are going to get y by power rule, you are going to get sec squared x tan of x. Again, you can check calculate trigonometric function. I have also provided the link below for those who have forgotten on how you can differentiate sec squared of x. This is by chain rule or by power rule. Combining power rule and the chain rule. Actually, here we are calculating, that is product rule, power rule, and the chain rule to conclude that this part is the same as the one below here. Kindly, you can check in my YouTube channel on how to differentiate by product rule. I will also provide the link below, which is equal to sec squared x tan of x. This can be written as sine of x divided by cos of x squared. Using the fact that 1 over cos of x is the same as sec of x. So 1 over cos of x is the same as sec x. So that is the fact I'm employing here. Then we multiply by dx both sides, so that on the left hand side we are going to be left with the d of y sec squared of x is equal to sine x divided by sine of x divided by cos squared of x, everything here and dx. Then we take integral both sides. We take integral on both sides. Now, when we integrate, and on the left hand side, we are integrating and we are differentiating. So when you differentiate and you differentiate and integrate your function, the result is that function. Because you are building is integrating, differentiating is demolishing. So if you build one step and you demolish one step, you will remain where you are. So that's why now here we have our function, which is written as y sec squared of x, which is equal to. Now, to integrate the left hand side, we are going to integrate this by what is called u substitution. So we are going to let our u to be equal to cos of x, then our du will be given by, when you differentiate cos of x, it will give you negative sine of x dx. You can divide by negative both sides to have du, negative du is equal to sine of x dx. And now, when you compare this one, sine of x dx, we will substitute it with the negative du, and the denominator with u. So this is equal to integral of negative du divided by u squared. That is what we obtain there, which is equal to negative can be taken outside the integral side, and we can also take the u squared du. So integral of u power negative 2 du can be integrated by power rule. So we add 1 to the index, so you have negative 2 plus 1, which will give you negative u power negative 1 divided by the index, which is power negative 1, plus constant c. This is equal to negative, and the negative will become positive. Negative 1 divided by negative 1 will become positive, and then you are going to have u power negative 1 plus constant c. You can write it as positive as 1 over u plus constant c, meaning substitution here. Then you can combine the right hand side. Here we have y sec squared of x is equal to 1 over our u. We let our u to be cos of x above there. So 1 over cos of x plus constant c. Then we divide both sides by sec squared of x to be left with y, which is equal to 1 over cos x multiplied by 1 over sec squared of x plus c over sec squared of x. We have divided both sides by sec squared of x, but we are going to make use of this simple rule, but 1 over cos x is the same as sec of x. So this is what we are going to employ. So finally, our result will be y is equal to 1 over cos of x multiplied by, instead of 1 over sec squared dx, we can write it as cos squared of x plus cos squared of xc. Finally, y is equal to 1 of the cos will cancel, cos of x plus c cos squared of x. So that is our result in those simple step method. Remember, here we have made use of calculus 1 and calculus 2 to solve this simple linear first order differential equation, which we were given as shown here, and also we have employed the use of integration factor. Thanks so much for watching this video. For more such video tutorials, kindly check my YouTube channel. Remember also to subscribe to this channel so that you don't miss a single video which I upload for us every day. Bye bye, see you in the next video.